All right, number one is an ellipse problem, and we're supposed to identify the vertices, covertices, foci, and eccentricity, and sketch the graph. So first thing I'm going to do is identify the center, actually. So the center is the opposite of the interior, so we've got x minus 1, so that's a positive 1 for the x, and then there's nothing here, so you think that it's y minus 0, so that would be 0 for the y. So the center is at the coordinate point 1, 0. And then we need to figure out what A and B are. So with ellipse, X is always first, but determining which one is major is figuring out which one is larger. And so A is the square root of 40, because the standard form has either x minus h quantity squared plus y minus k quantity squared over 1. If this is a squared, then that means it's oriented this way. And if it's x minus h quantity squared plus y minus k quantity squared, and this is b squared over a squared, and that means the major axis is vertical, and so it's oriented this way. Okay, that's the way that we tell the difference between them. In this case, the higher number is underneath the y, and so a is the square root of 40, and that's a vertical distance. Now 40 is 4 times 10, which is 2 root 10, but the square root of 40 is just over the square root of 36, which is 6. So it's 6 point something, so we're going to go up 6 point something. Although, if I wanted to know exactly, then I would go, having the square root of 40, 6.30. So 6.30, and down 6.30. So that's my major axis, 2A. And then B is the square root of 25, which is 5. So I'm going to go left and right 5. Which puts me at positive 6 here. And if I go 5 to the left from negative 1, or from 1, that puts me at negative 4. Okay. As far as my foci go, we got to remember that in an ellipse, you've got A, you've got B, and you've got the length C, and then we know that this length right here is also the length of, well, the way that I drew it, maybe not. We'll let C be over here. So C, and then we know that this length is also A. So A squared equals B squared plus C squared, or C equals the square root of A squared minus B squared. So if we take the larger number, subtract the smaller number, and take the square root of that, square root of 40 minus 25, that is the square root of 15. And the square root of 15 is just under the square root of 16, which is 4. So 3 point something. Now, because the major was vertical, that means the foci are vertical, so we're going to go up 3 point something. 1, 2, 3 point, close to 4. Really close to 4. And down. Okay. And then we sketch. So, to the best of your ability, create some elliptical shape. It does not have to be perfect. Mine definitely will not. Okay. Something of the sort. All right. And I cannot keep looking at that or I'll keep messing with it. All right. So on number 2, it says use the information. Oh, I forgot. Eccentricity. So identify the vertices by graphing them, the covertices by graphing them, the foci by graphing them. Although, if I were to write down the foci coordinate points, I would say they are at 1, because the x value is 1 for both, and then up and down the square root of 15, so plus and minus the square root of 15. I don't need you to write out the coordinate points for the vertices and covertices because you graph them, so that's not a big deal. You'll state them later anyway. But I did forget the eccentricity. Eccentricity is C over A. And if C is the square root of 15, and A is the square, or 2 square roots of 10, then I do expect us to simplify that. Okay. So just as a reminder, the square root of 15 divided by the square root of 10 Might as well just be the square root of 15 divided by 10, which is the square root of 3 halves. And I guess I could leave it like, yeah, okay. So that's like the square root of 3 over 2 square roots of 2. I'm okay with us leaving it like that. You don't have to rationalize. I mean, you could say the square root of 6 over 2 times 2, which is 4. That would be the most rationalized form. Well, there you go. Okay. Sure. All right. And number 2. Use the information provided to write the standard form equation of each ellipse. Okay, so the first thing I'm going to do is write out the skeleton of what I'm going to write. We always put x first on ellipse, and it always equals 1. A lot of people are leaving off the equals 1. Make sure that you're not one of those people. Okay, the vertices, we got -2, 21, and -2, -7. So it looks like to me that the thing that changed between my two vertices, which automatically means major because this is co-vertices, which means minor, was that it was a change in y, okay? Which means to me that y is the major axis, okay? So if I thought about this, if I were to sketch it out, if I go -2 up 21 and down 7, the distance between them is 2a. So 21 plus 7 is 28, which means half of that, a equals 14. If a equals 14 and that is vertical, then 14 squared, which is 196, goes underneath here. Okay. It also helps me find the center. So I already know the center is going to be at -2 something because it's in between these two coordinate points. Well, if half the distance is 14, then if I go up 14 from -7, I'm at +7. So +7, obviously this is not a good scale, but +7 would have to be the halfway point. So that would be -2, 7. So I can go ahead and fill that in. X plus 2, y minus 7. And then I need to figure out b. So 0, 7. So if I go to the coordinate point 0, what? Okay. I don't know why that's throwing me for a loop. Oh, I see. 0 up 7 and -4 up 7. Okay. That's why it was confusing me, because it was right at that point where I just labeled. Okay. So that means that distance between the two different x values is 4, which means half of that distance is 2, so b equals 2. And if b equals 2, then this is 4. And there's my equation. All right. Number 3, we need the equation, so I'm going to go ahead and start it. So let's see what we get. The foci are at -2 plus 2 square roots of 6, comma 1, and, sorry, -1 plus 2 square roots of 6, comma 1, and -1 minus 2 square roots of 6, comma 1, which kind of leads me to believe that the center is the coordinate point -1, 1, and 2 square roots of 6 is just a change from center to focus. So I'm thinking that C is 2 square roots of 6. I also can see that the endpoints of the major axis are 6, 1, and -8, 1. That's a change in x values, and it is a total distance of 14. So if you think, if I go to the right 6 and to the left -8, that total distance 2a equals, because this is major, is 14, which means a equals 7. Okay, it being horizontal to me tells me that the major goes underneath the x. I also could have gotten that from here because the focus went left and right, so that means major is x. So a is 7, that means this is 49. The center is -1, 1, so that means x plus 1, y minus 1. And if I know c is 2 square roots of 6 and a is 7, then, and I also know that a squared, 49, equals b squared plus c squared. So 2 square roots of 6 squared. A couple different ways to do that. 2 square roots of 6 squared is the same thing as 4 times 6. Or you can think of it as bring the 2 back in, take or square it, put it back in. The square root of 24 squared, which is 24. So I get that b squared equals 49. We're going to subtract that over minus 24, which gives me 25. Yeah. And there we go. That was kind of a weird way to write it. I'm going to do an intermediate step. 49 equals b squared plus 24. So b squared equals 49 minus 24. Maybe that makes better sense. All right. For the next one, I've got x minus quantity squared plus y minus quantity squared equals 1. The major axis is horizontal. That tells me that a goes here, or a squared, because it's oriented this way. The center is negative 7, 9, so I'm going to put x plus 7, y minus 9. Keeps being a negative and a positive. The major axis is 16 units long. That means that 2a equals 16, which means a equals 8. So we're going to put a 64 here. And the minor axis is 2 units long, so 2b equals 2, which means b equals 1. I don't want to put an equal sign there. Which means 1 squared is 1, and then there we go. That's my equation. Although, because it's 1, you probably just wouldn't have anything, and it would just be y minus 9 quantity squared. For number 5, we've got, again, the equation. All right. The vertices, we've got 13 halves, 5, and 13 halves, negative 13. So vertices in this case automatically mean the major. So I'm going to go ahead and think that out. 13 halves is 6.5, so it's over here. 13 halves, up 5, and down 13. Which means if this is my vertices, these are my major, then this right here is 2a. And it also means that a squared goes underneath the y. Okay? It also tells me where my center is. So my center is at 13 halves, and I could work it out, but I can also see that it's probably negative 4 just by looking at that right there. The distance between negative 13 and 5 is 13 plus 5, which is 18. So if 2a equals 18, then that means a equals 9. If I go down 9 from 5, I get to negative 4. If I go up 9 from negative 13, I get to negative 4. So negative 4 is my center, the y value anyway. So I'm going to put x minus 13 halves and y plus 4. Okay. I know that a is 9, and this is a vertical ellipse, so I'm going to put 81 underneath the y. Last thing I need to solve for is c. So not c. I know c. I need to find b, because I need b squared. So I know a is 9, and from the foci, I can tell that c is this distance 3 square roots of 5. So if a squared equals b squared plus c squared, then 81 equals b squared plus 9 times 5. If I square 3 square roots of 5, I square 3, I square square root of 5, and that's 9 times 5, which is 45. So I subtract 45 over, b squared equals 81 minus 50 is 31, so 36. Yeah, and there we go. Number 6. Number 6, I've got an eccentricity of square root of 3 over 2. I'm going to go ahead and write c over a, but be cautious about that because this is a simplified fraction potentially. So I know it should be the ratio of c to a. It doesn't necessarily mean that's c and that's a. So let's use this information to see what else. I know the center is at 3, 7. Okay. So I know I can plug in x minus 3, y minus 7. And I know that one of the vertices is at 3, negative 5. So if I were to plot this out and go 3, 7, so 3, 7 is my center, and then go to 3, negative 5, so 3, negative 5, somewhere here, and that's my vertex, one of my vertices. Then that distance right here from center to vertex is A. It's not 2A, it's A because it's from center. So this total distance is 12. Cool. If A is 12, and I know that that's vertical, then that means 144 goes underneath here. But then I also know that A is 12, so this is a simplified version of something over 12, so 2 times 6 gives me that, so I'm going to multiply the top by 6. And that tells me that C is actually 6 square roots of 30. I just put 6 equals. C equals 6 square roots of 30. Alright, A squared equals B squared plus C squared. C squared is 6 square roots of 3 squared. 6 square roots of 3 squared is 36 times 3. 90, 108. Okay, so I'm going to subtract 108. B squared equals 44 minus 8 minus 4 is 40 minus 4 is 36. So 36 again. Okay. For number 7, I know that my minor vertices, it looks like, are right here. My major vertices are right here. So in writing my equation, x minus plus y minus equals 1. I can tell that it's a vertically aligned or oriented ellipse, which means A goes underneath the y value. I know that my center is at negative 4, 1, it looks like. So that means x plus 4, y minus 1. I know that A is a distance from 1 to 7, which means A equals 6. So I'm going to put that 36 underneath here. And then I can see that the distance from here to here, from negative 4 until negative 1, is 3. And so that would mean that goes 9. And there we go. Use the information provided to write the standard form equation of each ellipse. State the center, vertices, co-vertices, and foci. I'm actually going to start that on the next video.